Hi, my name's Romy Lofthouse. I represent a small company in Reno, Nevada, Nozzle Technologies, LLC. We've developed a compressed air-driven nozzle. Originally, it was developed for the mining industry. We felt that by suctioning up placer ore, we could separate the placer gold from the ore using a collection device, and the nozzle as the suction device for the ore. As we worked on the nozzle, this is our little half-inch, one of our original prototypes. It's made out of aluminum. When we originally developed the nozzle for this mining, we also found that it might be used for other purposes. We found that the nozzle would actually suction and transmit through velocity water, various fluids, even gases, sandy materials, any material with a consistency that would fit through the nozzle. So anything half-inch minus will go through this half-inch prototype. We graduated up in prototypes and moved on to a 1-inch prototype. This is made out of a new plastic called Delrin. And because of the recent oil spill on the Gulf, we wanted to find out if we might suction oil off the surface of water. And we found out that we could do that. We wanted a material that would work well in salt water. The aluminum would not be good in that environment, so we went to this plastic, and we believe that it would work in a saltwater environment. I've adapted these ends with my machinist so that we can adapt various hoses to the nozzle. This is called a cam lock system, and as you can see, it works very simply. It just snaps on, and so you could switch hoses, put on hoses of varying lengths, and it'll work on both ends, male or female. So that's your cam lock fittings that we've adapted for this particular nozzle. And this is the 2-inch nozzle, which I mean by 2-inch ID. And it would be run by a larger compressor. Today's compressor, we're using a 750 CFM, cubic feet per minute, 750 cubic feet per minute, which will operate this 1-inch nozzle. And we'll do a little demonstration. We'll suction and blow some water, and suction and blow some sand, and I'll give you a brief idea of how the nozzle might work. Keep in mind that water is slightly heavier than oil, and that's why oil will float on the surface of water. So we found that if we can suction water, then we could certainly suction oil. And we have tested this half-inch prototype on oil on the surface of water, and it works very well. Hi, I'm Romy Lofthouse with you again, and we have the half-inch aluminum prototype. What we're going to do is show you how it works. We're going to suction some oil out of this bucket and disperse it, and we'll also suction some sand out of this bucket and disperse it. One important thing to keep in mind about these nozzles is that they never lose their prime like a pump might. This nozzle can go in the sand, back into the oil, out of the oil, back into the sand, out of the sand back into the oil without ever losing production. So it's a pretty consistent little machine, and it never has to be primed.
Hold on. Just stay still now, don't move it. Okay.
The compressed air injected nozzle may be used to suction and disperse various liquids, solids, and gaseous materials and transfer them through velocity. Although we have fully tested through the 2-inch size, the nozzle may be produced up to and above 6 inches, depending on the compressed air energy source.